Hello and welcome to this DDI CADcast on automating weldments. My name is Cody Armstrong. And like I said, the topic for today is going to be automating weldments. Now this is going to be a two-part CADcast series. The first part focusing on automating the weldment part creation, and the second part focusing on automating the drawing creation for weldments. So I want to jump right into it. First off, why automate anything? Well, it just generally makes tedious, repetitive stuff go faster. If you can automate tasks, they typically happen faster, and also you eliminate a lot of the human element to doing work, and therefore you eliminate a lot of the human or potential human error that's involved. So it just makes our job simpler. It saves time. It's also very cool, right? It'll definitely make your coworkers jealous. So it's definitely something that's worth looking into, especially when it's as simple as some of the things I'm going to show you here today. So who's this for? Well, this is really for the person that really wants to speed up certain repetitive things they do throughout the day, right? So if I do this, this, and this 4 or 5 times, 10 times a day, it makes sense for me to save those things as a macro, right? And to do those as repetitive tasks and to automate that. So that's really who it's intended for. This is not supposed to be real heavy into programming. We do go into some programming, so a little bit of background in programming helps. But I think if you're experimental and you're willing to play with it, you don't necessarily need programming background in order to figure out some of these things. I think the willingness to try things out is probably the most important bit of all of this, and just kind of test it and see what happens. So the ability to experiment, I think, is going to be important. But that's really who this is geared for. Why would I go to the API? Well, generally it's a last resort. I generally don't go to the API if there's a button or something else that can do what I'm trying to do. Another reason you'd go to the API is if you want to combine a series of commands. Like I always do this, I do this step, and 4 or 5 steps, but I'm always doing these 5 buttons in a row, and it's just a repetitive thing that I always do. Well, I can combine all that into a script in API and just run that one script. So that's an example where I'd use the API. And generally, problem solving is a lot of fun. Programming is a lot of fun, and if you can figure out a way to save time and have fun doing it, then what's the harm, right? So that's why I'd go into the API. Some alternatives to the API, well, we have the configuration publisher. And what I mean by alternatives is they're going to do similar things to what I'm going to show you today, but it's not completely everything that I'm going to show you today. You could probably get bits and pieces of from these different things, but there isn't one piece of software that'll do everything that we're going to do in terms of automation with the API. One example I'm going to go through is creating a weldment, using an API to automate creating a weldment, and you could do something similar with configuration publisher, right? You'd set up all your different configurations, variations, and then you go in and publish a configuration. So that's one other method for automating part creation and weldment creation more specifically. Drivers Express is another good tool for this. If you haven't used it before, Drivers Express is a tool intended for design automation. Basically, its sole focus is design automation. You write a bunch of if-then statements, and it builds a model on that. Again, takes a little bit more time to set up, but it is a very easy way to automate part creation, part and drawing creation. And then lastly, there are still those out there, a lot of people doing it using good old-fashioned design tables, right? Nothing very complicated about them. You're just really punching in values and building configurations in a spreadsheet, and definitely one of the favorite ways for a lot of users for creating configurations. But all these are examples of ways you can automate part and drawing design work and use no programming whatsoever. Right? So I just want to bring these up because if you're not looking to get into the API, these are things I would recommend looking into as ways to automate your part and drawing creation. Alright, so let's go real quickly through a workflow for creating a simple API script. An API script is just a macro, essentially. You're automating a series of commands. And so basically what I want to do is I want to make sure I plan ahead and know what those commands are. What 5, 10, 20 steps do I want to record, right? What 20 steps do I want to automate? Plan ahead, even write them down if it helps. And then what you're going to do is go through those steps with a macro recorder on, recording your every movement. So I'm going to show you in a moment where we get in, turn on the macro recorder, and it will essentially record every mouse click that we do. Okay. After that's done, we'll edit the macro and delete any unnecessary code. Okay. When we record macros, there tends to be some unnecessary code. And then you test the macro. If it doesn't work, you debug and you test again. So that's kind of the process for creating simple API scripts. Of course, I can get into more complicated examples where you're really building and it's much more programming. But what we're going to do today is much more macro recording than it is programming from scratch. So I have two examples for automating weldments. The first part of this CADcast is going to be a two-part series again. Part 1 is going to be automating weldment part creation, and part 2 is going to be automating weldment drawing creation. Okay. So for this one, we're just going to focus on part 1. So let's jump right into it. There are a few things I want to point out before we actually start an example. And the first is this macro toolbar that we need to have on in order to record macros. By default, it's off, but if I right-click up here, you'll see an option for a macro toolbar. You'll want to make sure you turn that on before we start anything. That's the main toolbar we're going to be using. You'll see it here. That's where we go about running, creating, recording, editing macros. Okay, so you want to make sure that toolbar is on before we start anything else. Now, like I mentioned before, we want to plan ahead the process. Okay. Then we're going to go through with this macro recorder, record, and then step through each one of the steps of our process. So that's kind of the general workflow that we're going to be taking. Now, some things to remember before I start. You want to avoid unnecessary movements. When you're recording a macro, it captures everything. So rotate, zoom, anything that's unnecessary, you want to avoid as you're recording a macro. Okay? Because they're not really needed. It'll add a lot of frivolous lines to the code that frankly will be hard to read and tends to confuse new users. So you want to avoid anything unnecessary as you're going through and recording your different steps in the macro. Now, what I want to do is just build a real basic skid, right? And I want to take you through an example where I build a skid and then automate that, showing how to record the steps and then edit the macro. So that's kind of my general process. That's my take on this automating a part. Let's go ahead and start by recording. So as I mouse over, you'll see a record pause button. This is where you start the record. You can also pause using this button. But as soon as I click, it says record. And now from this moment, it's recording. Right? So I go File, New. I'll start a new part. And what I want to do is I want to build a grid system. Like I said, my goal is I just want to make this skid. My company makes these skids, and I need to make them a little bit faster. So what I'm going to do is build the skid and then record it and then modify it. Right? Now these skids consist of a grid system. So the first command I'm going to call up is the grid system. I'm going to go ahead and call up a center rectangle. Okay? And we'll sketch a rectangle. Then what I'm going to do is call up a center line. Okay, I'm going to add a couple of extra lines to this rectangle. Notice as I'm going through this that I'm not adding dimensions. Okay, and that's on purpose. Last thing I'm going to do is add a symmetric relationship here. Then I can get out of the sketch. Okay, exit sketch. How many levels do you want to your grid system? I'm going to say 2. And then just hit OK. So now I've got my grid system in place. I need to show the components between them, so I'm going to go ahead and turn on this 3D sketch. Just say show. And then what I'm going to do is go through and add structural members to each one of those sketch entities. Right? So this is the same process I'd take to build this skid any other way, right? Any other mode. You don't want to do it any differently just because you're recording. So if I set this to 90, for instance, I want to set the same settings I would there. Okay, so 90, new group, I'll go to the next one. There's the next one. Again, I want to rotate 90. New group, we'll go to the top. Okay, 90. New group. These two middle pieces here. The last group is the vertical. Right, the long vertical pieces between them. We'll select all those. And again, really all I'm doing here is building my part. I take the same steps I take to build it the dozen or so times I've done it before. but this time I'm recording it. Okay? So now I've got that. I hit OK. And now my weldment is complete. I'm going to go ahead and stop the macro. Okay, so the little stop icon here, I'm going to hit stop, and then we're going to give it a name. Okay, stop, and we'll call this skid builder. So now we've saved this skid builder macro. The easiest way to test a macro is to just run through it again. Right? So what I'll do is I'll close this document and I'll just hit run on the macro toolbar and select that macro that I just saved. Hit open and it should run through the macro. Okay? You want to make sure to choose an SWP file. That's the file we're looking for. And then again, it runs through the macro, and there is my finished part. Okay? So that's the recording process, recording a macro from start to finish using just mouse clicks, just capturing the things you're already doing. So now that I've got this macro recorded, I want to edit it. And the way we edit it is using the Visual Basic for Applications IDE, Integrated Development Environment. Now, there are a lot of those that use Visual Studio, and those work as well. For the simplicity of this and for the ease of use, I'm just going to stick with the basic editor. Now, if I go to the macro toolbar, you'll see an Edit Macro icon right here. If I click on this, I can browse to my macro and then hit Open. What this will do is open my macro in the Visual Basic for Applications IDE, okay, Integrated Development Environment. And if you've ever used Visual Studio or Eclipse or any other common IDEs, this is very similar to those. It's got run tools, debug tools, it's color-coded, so it makes it a lot easier as a programmer to figure out what's going on. But this is kind of the generic IDE when you're building macros in SolidWorks. And like I mentioned, you could use Visual Studio or others, but this is the one I'm going to stick with for this particular CAD-cast. So I'm not going to go through what each of these things mean. In fact, if I look through this, it's pretty long code, and it can look a little daunting, especially at first. But I don't want to go through what each individual element means. I just want to kind of highlight what some of the more important bits are. Right? So if I scroll down here, you'll see there's quite a bit of code. And again, I'm not going to go through each one. I don't think it's really necessary if all I'm really trying to do is automate the part creation process. I don't need to know what every little thing is. So some things that are important though. These first top bits here, this is defining my variables. Right? So you want to define variables. Now these are what they refer to as early bind variables, which isn't all that important. But you're defining all this stuff right up front. Okay? So I'm defining SW app as an object, part as an object. You don't have to worry too much about what these things mean. You'll see here I've got my sub main. That's where the profile first starts. Right? So when I start this program, that's where it's going to start executing, under sub main. Okay? So obviously, I'm defining my variables. SW app equals the SolidWorks application. I've got new documents here. It's creating a new document. So you can kind of stumble your way through it and figure out what the commands are doing just by the names. But again, it's not incredibly important that I know what every little variable is. Right? So this app new document, that made my new drawing or new part, using that template. Okay, and I could see, okay, I've got start sketch here. And there's my top plane. I'm going to put it on the top plane. So you can kind of stumble your way through and figure out the gist of what's going on. And again, I want to stress that I don't think it's entirely necessary for everybody to know every single variable in here. Okay. So let's go back here, and I'm just going to run through this one more time. Now the big difference here is I want to single step through the program. And I can use the F8 key on my keyboard to step into the program. So if I hit F8 here, you'll see it highlights the sub main. If I hit F8 again, it runs to the next line. And so F8, this step into, is a way for me to step into line for line the program. So you'll see I stepped in, it created a new part. As I go through, now I'm going to highlight the top plane. Then I'm going to create a new sketch on that plane. Okay, now I'm in sketch mode. And then go through the next line. It's going to create a rectangle. Right, there's my rectangle. And then go to the next line. It's going to create center lines and then lines. So the F8, the step into, is a way of kind of single stepping through each line in your program. Okay, this is going to take a little while, so eventually I'll just run through this. But again, I just wanted to point this out because it's an easy way to troubleshoot what's going on in your code. I can step through line for line. Okay, and again, that's using F8. I'm just going to go ahead and run through this, and we'll run back through to the end. But again, I wanted to point out that step through, the step into function using F8 to step through your code. It's definitely very useful when you want to troubleshoot what's going on and see which path the code is taking, in what manner is it executing. Now, one thing you'll notice about this macro as it runs right now is after it finishes, I'm left in this zoomed in state of the model. Notice I'm way zoomed in here, and of course I could do a zoom to fit, and after I'm done running the macro, and that would fix the problem. But this is automation. I want to build that zoom to fit right into my program so I don't have to hit that button every time. And so that's kind of an example where I can just take it one step further. So let's go over an example where we edit this program a bit and add some code. Alright, so my goal is to add a zoom to fit at the end of my program so that after it's done running, it zooms to fit and it's no longer in that zoomed in state. Right? Now I could record this, right? Go to record on the macro toolbar, do a zoom to fit, and then capture the code. But what I can also do is call up the API help. And for a beginner programmer, the API help is going to be a huge benefit. There's lots of good examples to call up that shows the user how to do certain things. So I definitely recommend having the API help up at all times when you're programming in SolidWorks. So if I call up the API help, I can do a quick search. Let's say zoom to fit. And what you'll find is an example here, change to isometric and zoom to fit view mode example. So basically what this is an example provided by SolidWorks of an API call for a zoom to fit. Okay, it happens to also have isometric, so I'm going to ignore the isometric bit. Notice this says VBA. Okay, there are other examples here. You'll see some like this one says C#. You want to be careful about which ones you choose. This one says VB.net. VBA is what we're going to be using for this particular CAD-cast. That's our examples, and that's using Visual Basic for applications. If I were using Visual Studio, trying to write in another language, then I need to use one of those. Okay. So again, back to our script. This is the zoom to fit example, and all I need to do is steal some of this code and paste it into mine. Now I don't need this, but I do want the zoom to fit command. So you'll see it there. It's just swmodel.viewZoomToFit2. Now I'm not using this particular variable, okay, swmodel. That's set to the active document. I don't need that because in my example, we have that set as part. So let's go back here. I'm going to zoom up and let's find where I've set the part. There it is. Set part equal to the SW active document. That's really what's important. So I've set the part variable to the active document. I'm not using swmodel. Okay. So all I'm going to do is copy this. Go down to the bottom here. I want it to execute at the end. Okay, so at the very bottom here, I'm going to paste that code in. Okay. Now again, I'm not using swmodel, so I need to get rid of that. I'm going to change this just to part. And that's it. Once I've done that, I can do my reset and rerun it. But that's all it really takes to make a change to the program. So let's close this. And we'll reset and then run. Okay, so I'll hit run here on the Visual Basic application. And it runs through, and the last thing it should do is zoom to fit. There we go. Okay, so now after it's done building the part, it's going to do a zoom to fit, so that's no longer in that zoomed in state. So that's really all it takes to add a little bit of code. Cut and paste is a lot of what we're going to be doing in the API. So one thing you'll notice about this part, and the parts that this script creates, is that the cut list is not automatically being updated. So if I expand out the cut list here, you'll see all the different bodies. It hasn't grouped them together and created common cut list items, right? That's a separate step, and of course I could right click and say update, and that would force it to update. But this is automation. I want to build that into the script so I don't have to right click update every single time I run my script, right? So I want to build that into it so I don't have to do it. Just eliminate that step. Now this is a little bit more involved than what we've done up to this point. It involves a little bit more programming, but the nice thing is other people have done this as well. So here on the SOLIDWORKS forum, I found an example of how to do this, and I want to thank John for posting this. Here's a nice little script to update a cut list. Okay, real basic if-then statement to update a cut list, and again, it's contributed by the public. So the SOLIDWORKS forums are another great resource to find scripts that other people have generated, right? Something that you might use as well. So all I really want to do is I want to copy and paste this into my code, right? Make sure we define our variables correctly, and then it should run, right? So I copied this. Let's run back. I want to paste it into my code. Now, one thing I always recommend is commenting your code so that it's easy for other people to figure out what's going on. So here I'm going to type an apostrophe, and anything after the apostrophe will be ignored when executing the code, right? So I just added update cut list as a comment, and then I just paste my code in. But again, the apostrophe, anything after that will be ignored, so it's good as a comment for the person reading this code to figure out what's going on. Now what I need to do is define some of these variables. Right? These variables don't belong down here. These are early bind variables. I want to make sure they're defined earlier. So I'm going to get rid of them here. I'm going to move them up to the top of the part. Now, I need to define two variables. You'll see my feature and my body folder. Those are really the two variables that I need to define in order for this to execute. Right? So scrolling back up, those are the two that I'm going to add in. So I'll go back to the top. You'll see I've added dim my feature as SOLIDWORKS feature. Right? So there's my first variable being declared. And then I have the one just above that, dim my body folder as body folder. Okay? So I've declared both variables. Now body folder, SOLIDWORKS features, these are all type libraries that are included with SOLIDWORKS. So I don't need to define body folder, for instance. It knows what body folder is because of the SOLIDWORKS type library. Now if I go to Tools References, I always like to check this to make sure it's current. Okay, if you go from a version to version, you want to make sure that the current type library is loaded as a reference. Okay, that's all. If you have multiple versions, that can create issues. You want to make sure that the most recent version is loaded. But again, that's the reason I don't need to define some of these things. Okay? So now I've defined my two variables. Here at the top, early bind variables. Now I want to do is go down to the bottom and set these variables. Now there's two steps to defining a variable. You first have to define it, right? Dim whatever it is, and then set. So here I'm going to set my feature equal to part, which is our active document. Right? So if I go back up to the top here, part equals SW active doc. So the part is the active document, and I want to say part dot first feature. Okay, so I'm saying first feature in the tree. So the my feature is equal to the first feature in this part's tree. Okay, now I've set that variable. Now I'm going to set the body folder variable. So I'm going to set my body folder equal to the my feature dot get specific feature variable. Okay. And so now I've set those two variables. The last step here is I want to set my feature after it's all done to the next feature. Okay. This is going to loop, so I want to make sure that it's set to go to the next feature after the first. Right? After the first is done, go to the next. So now I've set each one of the variables. I've defined them. Now I'm ready to run the code. So let's take a look at what this is going to look like. Okay. If I go back to SolidWorks, we'll go ahead and close this down. Okay. Notice cut list not up to date. Go ahead and close it, and we will run our code. Okay. After this is done, it should do a zoom to fit, just like before. Then update the cut list. Okay. Now if I go to my cut list, you'll see it's up to date. Everything's been grouped, common items together. Okay. So that's updating the cut list via an API script. Alright, so I've updated the cut list. The next thing I'd like to do is make sure this thing is the correct size. And like I mentioned when I first built this, I'm not adding dimensions. And the reason for that is I build those right into the actual macro. Right? So I don't need to actually dimension the model as I'm recording it because the macro will apply the correct values. And I also want to create a different version. Right? So I'm going to take you through an example of that. But as we stumble through this code, a couple things I want to point out. It creates a sketch on the top plane. I already pointed that out. But here, it creates a center rectangle. So you'll see the command .create center rectangle. You also see a series of numbers after that. We have XY position as well as the size. That's what these values are after any geometric shape, whether it be rectangle, lines, circles, doesn't matter. It's going to have a series of numbers after that command to dictate where it is and what size is it. Okay? And I also have it down here, create center line, create line, as well as the values for that. Now these values dictate the size. Okay? So those are really the values I want to change in order to get this model to the correct size. Now some things to note, those values are always in meters. Right? That's why they never correspond with what you're typing in, because by default it's always going to be meters whenever you're recording a macro. So you'll have to convert your values to meters in order to spit this out. So an easy way to do this, and I find I like this tool, is just to do a Google search. Right? If I do a Google search and I say 36 inches is equal to blank meters, it has a calculator built right into it. Now they're unit conversion calculators, but this is easily accessible, and I definitely like this format. So now 36 inches is equal to 0.9144 meters. Now, when I look at the values, I'm not going to type in 0.9144. It's a center rectangle. It's going equidistant both directions, so I really need to cut this in half. Right? 9144 divided by 2 equals 4572. So 0.4572. That's the value I want to set for my center rectangle and the lines that are in that sketch, that very first sketch that I drew. So let's go back to our script, and what I'm going to do is literally type in 4572 for the value for the size of each one of those shapes. First for the center rectangle, right? 4572 here. It's equal, right? So 4572 for both. Then I need to go to the lines, the center line and the regular lines. I'm going to change their values to 4572 as well. And I'm just resizing these lines to be the correct size, because when I initially recorded this, they were not the correct size. Okay? So lastly, I add the 4572 here and here. And now all the values have been modified. Right? All the values that drive the size of this thing have been modified. So now if I save this and rerun it, let's go ahead and close this one down. I'll go ahead and rerun this macro. It should build it to the correct size, okay, which in my case is 36 inches. Okay? You'll notice it looks a little different. One way to verify is to actually go into the sketch that drives all this and do a measure. All right, we'll call up evaluate, we'll do a measure, and I'll just select one of the edges here. Notice 36 inches. Okay? Same thing goes over here, 36 inches. So now it's the correct size. And again, the size is all dictated by those values that I was editing in the macro. Okay? So now we have it to the correct size. So now I've got this thing to size, and what I'd like to do is build a form so that the user building this has a nice interface for doing so. Also in the form, I can build multiple versions of this. So if I go back to Visual Basic, you'll see a button here, Insert Form. And from here, I can build a user form. Now, if you've ever used Visual Studio or Eclipse or any other nice IDE, they all have very similar drag and drop like approach. So I just drag a label out here. Let's go to View, turn on Properties. And I can see all the properties for my label. We'll rename this. We'll call it Skid Builder. Skid Size. Let's say Skid Size. Okay. I can change height. I can change any other property that I wanted in the Property Explorer here. So again, very similar to Visual Studio or any other application, any other IDE application you may have used. So here I've got this label. Then what I like to do, let's go ahead and let's drag out a couple of command buttons. Okay, I'll just copy, control drag this one. We'll create another, and we'll create another. Also, we'll drag, actually, let's rename this. Let's go ahead and rename this 24-inch skid. Okay, and what I want is a button for each size skid that they can create. So this one will be 36-inch skid, and go to the next one. That one will be 48-inch skid. Okay. And I also need to add an exit button. So I'm going to go ahead and drag out another command button, and we'll just call this one exit. Now the way I program this is, first off, I need to set the name of it, right? So it's not user form 1. I'll go ahead and call this Skid Builder. So there's Skid Builder. Okay. And then I go through and I double click the thing I want to program. So in my case, I want to double click the 24-inch skid. Now, be aware of the fact that it's behind. The code that you've written is still behind the form. So it's all still there. It's still going to run through the same code. In fact, what I'm going to do is just copy and paste all this code. And basically what I'm going to tell the software is when I click this button, execute this code. Okay, so I go down all the way down to the bottom here. I'm going to copy that code. I'm going to go back to my user form. I'm going to double click the 36-inch skid button. And that's going to take me into the command for that button. So anytime that command is executed, it's going to do this. So basically I just copied and pasted the code. Now I have an extra N sub there. I go ahead and delete that. But basically this is the same code that I had just a moment ago. But now it's running on the command button 3, right? Or button 2, excuse me. So now it's going to run when that command is executed. So let's go ahead and try it. I'm going to go ahead and run the macro. It brings up my user form. Then I hit 36-inch skid. Now here I've run into a runtime error. And if I hit debug, it actually tells me what line is erroring out on. So you'll see this SW active status part 1. I never want to have a hard-coded reference like that. And it doesn't really help me. This is one example of one of those frivolous lines of code that you get when recording. So I'm going to go ahead and comment that line out. So you'll see I add an apostrophe there. It'll turn the line green, meaning it's no longer being considered when running. And let's go ahead and try it one more time. Again, notice it shows up green, meaning it's not executing. Okay, and we'll close that and let's run this macro one more time. Okay, 36-inch skid. And it builds my 36-inch skid. Okay. Now, you'll notice that this application, if I hit exit, it does nothing. There's nothing programmed for that button right now. So I'm just going to use this close. And that's a real easy fix. Okay. If I go back to my user form, I'm going to double click exit. And all I want to do here is run end. So when I hit exit, just run end. And that'll end the application. Okay. So now really all I need to do is copy and paste this same bit of code 2 more times to create the other 2 versions, right? A 24 and a 48-inch size. I've already got the 36-inch done. So I'm going to copy and paste this code into the 24 and 48-inch version. So there's the 24-inch. We'll paste that code in. Okay. Comment out the line I don't need. Okay. Then what I'll do is copy and paste this to give me the 48-inch version. So really I'm just taking the same lines of code and executing them in over different buttons. Right? So here's the 48-inch skid. I double click there. I'm going to paste all that code under that 48-inch skid button. Okay. Now all I really need to do is go through each section of code and make sure those values are right. Right? So those XY values that I was altering earlier, right? So if I go to 48-inch, for instance, it's 1.2192, right? 1.2192 divided by 2, 6096. So now I've got to go back to my macro, and for the 48-inch skid, I need to edit all the values to 6096. So I've gone through and I've replaced all those values, and really all I have left is to test it. Right? So let's go ahead and go back to SolidWorks. We'll close this. And I'm going to go ahead and hit run. And we'll first test the 24-inch skid. Right? So I hit 24-inch skid. It builds my 24-inch skid. Okay? I can now hit exit and it works. And again, the ultimate way to test this is to edit the sketch. So let's edit the sketch. We'll do a quick measure to see what that value is. You'll see it's 24-inch. Same thing over here, 24-inch. So the 24-inch skid version, the 24-inch skid button is now working. Let's close that one. And we'll go to the 48-inch. Okay, again, click 48-inch skid. It builds the 48-inch skid. And I exit. Okay. Now again, I'll just verify real quickly, make sure it's actually 48 inches. There we go, 48 inches. Okay, same thing over here, 48 inches. So I've built those other two versions just by copying and pasting the existing code. Okay. Well, one last time, and this time we'll build the 36-inch skid just to verify everything's still working fine. Okay. So there's the different skids, and there's the utility to build my skid tool. Okay. Again, I'll just really quickly verify 36 inches. That looks good. Okay. So that's kind of how I'd go through automating the part creation process. Right, capture some code, modify it a bit, make it fit what I'm trying to do. So that's it for the first part of the two-part series on automating weldments. Please visit us at www.ddicad.com.